when do they suddenly stop sending the live session? Okay, so where was I? Okay, so for in order, I'm sorry YouTube, I did not realize the stream suddenly ended. Okay, so for pre-order, in case you miss, pre-order, in order, post order, we imagine that we traverse throughout the tree, and we try to go left. If we cannot, we go right. If we cannot, we return, like that. So we first go left, and then go right, and then return, if possible. Like that. Okay. So for pre-order, we notice the order of appearance of the circles throughout our journey, and for in order, we only consider the squares, the middle part of the node. So let's see. So from here, we see from number 1, we see circle. Is circle a square? No. We go to number 3. 3, we found a circle. It's not important. We found a square. So if we found a square, so we put a square. And we put number 3. And then we return. We return to number 1. We see, oh, we now meet with the square. So we put number 1. And then we have number 2. We go to number 2. Is 2 the middle? No. 2 is not the middle because we found the circle first. So we go to number 5. We go to number 5. Oh, number 5 has a circle. Not important. And then we go to square. Is it important? Yes. 5. And then we go to number 2. And finally, we go to number 4. Like that. Okay? That's it. Now, for practice, for in-class practice, what is the possible if I were to consider the post order, what is the arrangement of the numbers according to the appearance? Okay, I'll give you some time to do this. Probably this is a Z, so I'll give you around 2 minutes. So you can put it in the chat for YouTube as well. If you want, you can put it in the chat. Let me just give you another one. Let's see. Meanwhile, let me just put up some codes for you. Is it the attendance? Okay, there you go. April 2023. Okay. Anyone got an answer? Or should I call your names? 3, 5, 4, 2, 1. Okay, that is from Fatiha. Any other answers? You may have the same answer or you may have the different answer. Okay, Azim wants to go with 3, 5, 4, 2, 1. So the answer for this is 3. So we consider the triangle, okay? So we go through our path just now. So we go down, circle, circle, circle. Okay, triangle. So we met with a triangle, we put number 3. And we go back, okay, square, circle, circle, square. Oh, we found another triangle. It is on number 5. So we put number 5. And then we go square, circle, square. We found another triangle. So we put number 4. And we go back, we found another triangle, which is number 2. And we found another triangle, which is number 1. So the answer is 3, 5, 4, 2, 1. So that is the answer for the post order. Okay. So now how are we going to do this? How are we going to implement this? Has everyone understand how does pre-order, in-order, post-order works? If no, you may ask the questions here in the group, in the Google meeting, or you can ask in what do you call it, in YouTube as well. If no, let me just drop the code for you guys. So the code for today's session is traversing trees. So that is the code for the session, traversing trees. So for the students who is class with Madam Rashida, please put this session code in as your token of attendance. Okay. Okay, traversing trees. Okay. The link of the Google form has already been given in the WhatsApp group. So you can we can click the link there and fill them up. Okay. So if there's nothing, we can proceed with the second part, which is the coding. So for the coding part, let us return here. So what do? we want to, the function is pretty much easy, because why? So what do? We define a function like print pre-order. What do? We take a node, we check if the node exists. If the node exists, so let's just ignore this. So okay, so define print pre-order node. So basically, let us just ignore this first for now. So usually what do we do is that before we introduce the pre-order, in-order, and post-order, we just check if the node exists. We try to go left. This is a type of recursion. This is a type of recursion where we call the node and we take the left branch, we call them again. We check if the left branch exists, we go on the left again. Or if they do not exist, we check on the right branch. If the right branch exists, then we traverse that branch like that. So what happened here? What happened here is that for pre-order, we want to print out the node value before we go to the left branch. For in order, we would like to print the value in between the traverse, after the left branch, before the right branch. For post order, we want to print the value after we have traversed both left and right branches. That's basically it. I'll go in there for the binary sort, but we'll go first for this. So let us run this. So when we run this, we can see that it agrees with what we have shown here. So for pre-order, we have 1, 3, 2, 5, and 4. We go for the in order, we have 3, 1, 5, 2, 4. And the third one, for post order, we have 3, 5, 4, 2, 1. This is basically the code. Nothing much. Okay? Nothing much. Okay? Remember, for pre-order, we print the value before we go into the branches. In order, we print the value after the left branch, before the right branch. And post order, we print the value after we go to both branches. That's all, basically. Now, let us go in, since we are on the topic of binary tree, let us talk a bit about binary sort. So we have learned about bubble sort. We also have learned about the, I don't remember another sort there, but during the early days of learning programming, you have learned several sorts. The one is the bubble sort, and one is the insertion sort, or the other sort? The sort where we compare what is the largest, and then which is the second largest, which is the third largest, which is the fourth largest, like that. Okay. So now let us learn about the binary sort. The binary sort is basically, we want to check whether let's say we already have it. Let us just do this. Not this one. This one. Hierarchy. This one. Okay. This one no need. Okay. So let's say I want to put number. What does binary sort does? Okay. So let's say I want to put number, any kind of number. So let us begin with number 5. So 5, since this is the first time the tree is created, so 5 is the root node. Now, we want to put number 6 in the tree without specifying which one to go, but we want them to be sorted. So what do? We put number 6. Let's say we add number 6 here, and we compare with number 5. So let's say for now, I want to say that the left side is lesser, and while the right side is more. Okay, more. This is less. So let us go for number 6. 6 we compare with number 5. Do they have this? Is 6 bigger or smaller than 5? 6 is bigger than 5. So what do? We go to the right side. And the right side is empty. We put number 6 there. Now let's see. Let's say I want to put number 2. Number 2. 2 is 2 greater than 5 or smaller than 5? 2 is smaller than 5. So we go to the left branch. Left branch is empty. We put number 2. Now, how about number 3? Brother, how about number 3? So number 3, we put it here. We compare. Is 3 larger than 5 or smaller than 5? Smaller than 5. We go to left. Is 3 larger than 2? No, yes. So we go to the right. But it is still smaller than 5. But since we already go left, we compare with number 2, we go right. So 3 is here. So we go back here, we put this 2. 3. For the sake of this, I want to put it in terms of both. So 3 should be here. So how about the other numbers? Let's say I want to put number 1. I put number 1, I compare with number 5, smaller than 5, put number 2, smaller than 2, so we put 1 here. So 1 is here. How about number 4? Number 4, we get even further. 4 less than 5, is it more than 2? Yes. More than 3? Yes. So 4 is here. So we go here. So we put here 4, like that. So 4 is here. And for the sake of this, let me just put it like this. Smart art design, right hanging. Not this one. Right hanging, like this. And how about number 7? And how about number 8? Number 8 is greater than 6, greater than 5, greater than 6. So we go to the right side. So 6 have a new child. 3, 8 here. So this one, we erase this and we make it right hanging. Not this one. This one, right hanging. How about number 7? So let us put number 7. We put number 7, it is greater than 5, greater than 6, but smaller than 8. So what do? We put it on the right side. 7. And for this one, let me just put it both. Just because I want to put number 9 there. Both. So we put number 9. We go down. Okay, greater than 5, greater than 6, greater than 8. So we put number 9 here. So here, 9. But brother, how are you going to read? How are you going to know that if it is sorted or not? Now, here's the question. It relates with the orders that I've mentioned before. So, which order will guarantee you that you will get the following you will get the sorted number from this binary tree. Is it the pre-order, the in-order, or the post-order? Which order that when you try to implement on this tree, you will get the numbers going up from number 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Which one? Do we have to focus on the circles, the squares, or the triangles? I only give you 1 minute because it's easy. This tree, which order that when we apply the function that we just code just now onto this tree, meaning that we go left, we go left, we go right, we go back, we go right, we go back, and everything, we will get the numbers sorted from 1 to 9. Even though we put the numbers in the order of the number that we put just now is gibberish. Like we put number 6 and then number 5 and then number 3 and then number 4. Okay, Moni said in order. Is anyone else have another opinion? Probably pre-order or post-order. Fatiha said in order. Yes, definitely not pre-order, definitely not post-order. So the answer is in order, because when you consider pre-order, you will meet with 5 to 1. This is not increasing. If you put post-order 9, 8, 6, 5, that is not the answer. However, if you consider in order, you go down, you meet with number 1, and then you go number 2, 3, 4, you go left, you found number 5, you found number 6, you go number 7, number 8, and then finally you met with number 9, like that. So the answer is in order. Okay, so how do we implement this? It's simple. So define insert, or if you want to make it binary sort also can. Define binary sort node val. So the node is basically the root node. Okay, the root the node that we want to place the value. Okay, so we check if the node is none, we return node.val. If the node is not empty, what do? We check if the value is the same, then we just return the value. So this is not important. However, if it is less than the value, then we put it on the if the value that we want to give is greater than the value that they have, we go to the right branch. Else we go to the left branch, like that. So now if we were to run this, you will get this. The in order traversals will guarantees you that the order will be in ascending order. Or if you change the signage, if you want to change, also can, no problem. If you change the signage, it will be reverse. So it will go in descending order. So it depends on the question or however you want to make your code is. Okay. So let's just change it back. Okay. So we can see that the pre-order, we have 10, 9, 12, 11, 13, basically we assign the value on the branch there. See, node the R branch equals to insert node the R branch, comma, val. Like that. This is where we assign the value. Okay? Has everyone understand about this binary tree and traversals? How about YouTube peeps? Are you okay? Everyone is okay. Alhamdulillah. Okay. If nothing, so this possibly marks the end of our algorithm learning. Okay, where you have learned about basic Python, the linked list, the hash tables, the binary trees. I can say to you that there are plenty more algorithms outside there, the data structures. For example, you haven't learned about the graphs. You haven't learned about the linked list. I haven't touched about the bidirectional, meaning that you can go back to the previous node. I did not mention about the bidirectional graphs, which is did not mention about the graphs, the trees, any kind of trees, meaning that you can also have one parent have many children. Also can you can also you haven't learned about DFS, depth first search, and breadth first search. Both of these searches are important in graph data structure. However, since it is not covered, so I won't be covering it here. You also haven't. I also did not demonstrate about the heap and stack, knapsack, fractional this, fractional that. Although it does exist in the syllabus that you guys have learned, but we did not implement it in here. However, I must say, let's say if you are going to go for competitive programming, these algorithms are very, very, very important. It is also important in real life, but if you are going to join any competitive programmings, these algorithms are useful for you to do, for you to implement in your coding to solve the problems. Okay? So since you have reached the end of the technical stuff, starting next week, we are going to have 2 classes about the graphic user interface, specifically in Python. Okay? Where we are going to learn how to use tkinter as our library. Okay? So this is the basic one. I will show it to you one by one before we go for the and then for this is for the first class. For the second class, which is inshallah after Raya, we are going to use Google Meets from Madam Rashida, where we are going in depth and going to learn about the pesky stuff in here. So we have, so for this is the basics of graphic user interface, and this is the advanced graphic user interface, which involves combining the coding that you have learned, the technical stuff, as well as how would you like to represent it in terms of your function. So you have the clear input, you have the update action, we have the push data, enqueue data. This is basically some data. This is pop data, queue data, clear list, delete data. Fun fact, I made this in just 1 or 2 weeks. Yep, I just made this in just 1 or 2 weeks during my before the last class. Okay, on the first class of GUI, I showed how my progress is for this for this programming. And the last one, Alhamdulillah, I managed to finish it on time, like literally the day before I finished the whole thing. Okay, so we have the grid forget, we have the pack forget, we have, this is very, 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 very hardcore, but we will start with this first. Okay, so I think that's all from me. So let us go for the task. Let us just clear this. Okay, so for now, this is this task is going to be your last task, because for the following weeks there will be no new tasks that will be given. Okay, as you guys will be implementing GUI in your projects, so I won't be giving you any tasks. Okay, so for the final task, you have 3 tasks basically. Okay, please read the PDF file that I have given to you. The first one, you need to write task A in one Python file, meaning that 5A should be in one Python file, while task B and C in another Python file. Okay, both of these 3 tasks should be done in different Python files, because the first one involves pre-order, in-order, and post-order traversals, where the second one involves binary sort, as well as some challenge there. Okay, so let us begin with 5A. 5A is simple. 5A is simple. You need to create a binary tree as well as 3 external functions: print pre-order, print in order, and print post order, that displays the binary tree in their respective order traversals. Okay, so I will give you this code. I will append this code to your code to check whether your code is right or not. And since you may use my code, however, I would like you to adapt to whatever appended code that I have here. So for example, root.left, root.right, root.left left, right left, left right, left right, left right, right right, and everything. Okay. So for 5B and 5C, this is where the challenge comes in. For 5A, you need to create an insert sort that utilizes the binary tree structure to auto sort strings being added to the binary tree, meaning that I will give you the order here. Root equals to node, my name, and then insert sort this name, this name, this name, this name, this name, until the end. Okay. And implement also the 3 external function from 5A. So you need also implement this tree. You can just copy paste, no problem. However, for 5C, 5C is definitely a new task. Okay, this is very challenging, so I have to give you 4 points instead of 3. Okay, because this one I haven't teach you. However, you need to implement this and try to get it yourself. If you manage to get this, I will give you full marks. Else, I don't know. I will still give you 3 or 2 marks, but if you really do it well, I will give you full marks for this one. 4 marks, which is not much, because it just counts 10% of your 40 total marks. Okay. Okay. So what is the task? What is the task telling us to do? So it says implement an internal function. Remember, internal function, deepest branch. Okay. that finds the deepest branch in the binary tree from 5B. Okay, from 5B. If there are several of them, take only the first one. Remember, take only the first one. Display the depth of the branch as well as the path taken to get to the branch. Use left or anything equivalent for left branch and right or anything equivalent for right branch. That's all. This question is challenging because you need to output everything. You need to output the depth of the branch. You also have to output the path taken to get to the branch. So, I bid you good luck for task 5C. Okay, are there any more questions? Because we only have about 5 minutes. So any questions? I'll open to one question only, one or two questions. One from the brothers, one for the sisters also can. Or if the sisters are shy or the brothers are shy, anyone can ask. No question? No question. If no question, so we end our class with Tasbih Kafarah and Suratul As. And I hope that inshallah all of us get the chance to witness the Laylatul Qadr. Okay. Sadaqah. Okay. With that, see you inshallah next week. Next week, before that, next week, I'm thinking of conducting the class during Tuesday instead, because I'm thinking Wednesday some of you might want to pack some things and want to go back to your hometown. Okay, so I'll do the class on Tuesday night instead. Okay, I'll tell everyone in the class. So if you can free your time during that time, you can come. Else, you can just look at the stream one. Okay, YouTube. Okay, with that, assalamualaikum. Let me just stop this YouTube first.